everyone, let f of x equal cosine x plus square root of 3 sine of x. And we're between 0 and 2 pi. The y-intercept is 0, 1 here. There's a minimum point at A, which is P, Q, and a maximum point at P. So first we're going to find the derivative and then show that Q equals -2. So let's start there. We have this point here is P, Q. So to find the derivative, we do f prime of x. The derivative of cosine is negative sine, and plus square root of 3, and the derivative of sine is cosine. So that's that part. Hence, show that Q equals -2. So basically, that means you set this to 0 and solve for x. You get sine of x, add sine of x to both sides, equals square root of 3 cosine of x. Divide both sides by cosines, you get tan of x equals square root of 3. So x equals pi divided by 3 and 4 pi divided by 3. That means we're going to use 4 pi divided by 3 because this is down here. This part will be pi divided by 3, and this one is 4 pi divided by 3 because it's in the different quadrant. This is quadrant 1, and this is quadrant 3. All right, so now we have to show that Q equals -2. So we're going to plug this number back into our original function. So f of 4 pi divided by 3 equals cosine 4 pi divided by 3 plus square root of 3 sine of 4 pi divided by 3. You want to put parentheses, you can. All right. Now this is going to equal -1/2 plus square root of 3 times square root of 3 divided by 2. This gives us -1/2 plus, this is negative, minus square root of 3 times square root of 3 is 3 divided by 2, which is -4 divided by 2, which equals -2. So this Q here is -2. It says verify that it's a minimum point. Now the way you do that is what we need to know is if it's a minimum, then this part, when we take the derivative, is negative, and this part's positive. So it should go negative to positive. So what we're going to choose is two values to do this derivative. So what I'm going to use is, we know this is 4 pi divided by 3. So I'm going to use pi and 2 pi because this is where we're at in between here. So I know that if I plug in pi, I can see if this is negative and this is positive. So what I'm going to do is take our derivative, which is f prime of pi, and plug that in. So our derivative again was negative sine of x plus square root of 3 cosine of x. All right, so plug that in. And that's going to give you, this is 0, minus cosine of pi is -1. So minus square root of 3. So this is less than 0, so it's negative. Now do f prime of 2 pi. So you get negative sine of 2 pi plus square root of 3 cosine of 2 pi. So this is 0 plus cosine of 2 pi is positive 1. So this is positive. This is greater than 0. So that means we have negative, positive. So that's how you verify that A is a minimum. Contrast this to if this was positive and then this was negative, then B would be a maximum. All right, now we have to do the final part, which says find the two more parts. Find the maximum value of f of x. So for that one, remember this was pi divided by 3. We got that, so just plug that in. So we have cosine f of pi divided by 3 equals cosine of pi divided by 3 plus square root of 3 sine of pi divided by 3. So this gives you 1/2 plus 3 times the square root of 3 divided by 2. That gives you 1/2 plus 3/2, which equals 2. So that means the minimum value of f of x is 2. So this is pi divided by 3 comma 2. And this one is 4 pi divided by 3 comma -2. From here to here. Now finally, we can write this in this form. Remember, r is your amplitude. So we're going to write f of x equals, your amplitude is 2, because you're going up 2 and down 2 from the center line. So that's just going to be 2 cosine of x minus, and we're shifting this since this graph to pi divided by 3. So it's pi divided by 3. So r equals 2 and a equals pi divided by 3. And that's it. Thank you. Have a nice day. Bye-bye.